Welcome to section 8.7, solving systems of inequalities. We lose our intersection point as a possible solution. So we're either going to have no solutions or infinite solutions. And all these solutions are on the graph. We have to shade all the possible points. So there's two ways to graph your linear lines. One, first equation. Notice that 1 in front of the x, 2 in front of the y, divide evenly into the 4. We can solve this by finding x and y intercepts, because when I want an x-intercept, the y-coordinate is 0. When I want a y-intercept, the x is 0, and I can plug those in. So if I take this 0, plug it in for the y, this becomes 0. Well, it's zeroed out. I don't need it. X equals 4. So here's a little trick. When you want to find the x-intercept, cover up the y term, solve for x. X equals 4. All right, so let's try that for the y-intercept. All right, I'm trying to solve for y. I don't want the x. Cover it up. 2y equals 4, y equals 2. Yep, you put 0 in for x, that's gone. Solve for y. There you go. Plot your two intercepts. 4 on the x-axis, 2 on the y-axis. Straight line. Use a straight edge. There's my line. Now, if you don't have a straight edge, you can find the slope from point to point. Down 2, right 4. Or reduce it to negative 1/2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Or reverse it. Up 1, left 2. Up 1, left 2. Up 1, left 2. Now, shading. I have to shade either below this line or above this line. So since I'm working in standard form where x and y are on the same side, I need to test a point. And the best point to test is the origin. Because we're going to zero out. I'm going to put 0 in for x, 0 in for y. Both terms zero out. 0 plus 0. That's always going to make the standard form of the equation, x and y on the left side, always a 0. Is 0 less than 4? Yes, that's true. Shade in the direction of the origin. So I'm not going to shade everything. I'm just going to draw arrows that I need to go in this direction. Second way to graph. Now, still standard form, 2 and 1 will divide into 0, but the answer is 0. Both my x-intercept and y-intercept will be the origin. I need 2 points to graph my line. So here, solve for y and put it into y equals mx plus b form. All right? So when I'm in y equals mx plus b form, the greater than symbol tells you to shade above the line. If it's a less than symbol, you shade below the line. If there's no equal to line, you graph a dashed line as opposed to a solid line. So here, my y-intercept is technically 0. Slope, down 2, right 1, down 2, right 1. Or I could go in reverse, up 2, left 1, up 2, left 1, up 2, left 1. Plot all the points you need to draw your straight line. Again, because this is a greater than, we shade above the line. This really says, let's pretend we're at the origin. Here's my point, 0, 0. My y-coordinate 0. This says I want all y-coordinates greater than 0. I shade above. Now, where the red and blue arrows point at each other and overlap is my shaded region. That's right in here. Any point in this region will make your system of inequalities true. So, for example, let's pick a point. We could test 1, 1 right here. 1 plus 2 times 1 is 3. Is 3 less than 4? Yes. 2 times 1, 2 plus 1, 3. Is 3 greater than 0? Yes. Okay, let's go somewhere down in here. 1, 2, 3. Down 1. 3, negative 1. 3 plus 2 times negative 1 is negative 2. 3 minus 2 is 1. Yes. 1's less than 4. True. 3. 6. 3 times 2, 6. Plus a negative 1 is 5. Is 5 greater than 0? Yes, true. So this is my solution set. Oops. Now, when you're in my math lab, you graph both lines, and to shade that region, there will be an icon in the shape of a bucket, like pouring out paint. It's like a paint bucket. All right, it's called the fill icon. So you click the fill icon, then you go to whatever region you want filled in, and you click it, and it'll shade everything in for you. Okay? All right, to my next example. X squared plus y squared less than or equal to 25. That's a circle. Y less than or equal to x squared minus 5. We have a parabola. All right, let's look at the circle. Treat it just like you've done in the past. It's like it's an equal sign. We have our center is at the origin, and our radius is 5. All right, now your symbols, what does that mean? Less than, okay, I want all points that give me a radius that's less than the 5. So this will be shading the inside of the circle. If that was greater than, I want all points that would give me a radius greater than 5. I'd be shading outside the circle. All right, so from the origin, 5 to the right, 5 up, 5 down, 5 left. Remember, don't forget your 3x4 and 4x3 points in each quadrant. There's my circle, shading to the inside, so I point my arrows inward. To graph my parabola, just like we did before, use that pattern 1, 3, 5, 7. My vertex is going to be at 0. Nothing's being added or subtracted to the 5. And here's my minus, or my plus k, which is a negative 5. So I'm starting at 0, negative 5. And I'm going to use my 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5 pattern. There's my starting point. 1 to the right, up 1, plot a point. 1 to the right, up 3, plot a point. 1 to the right, up 5, 1, 2, 3, 4, I'll be darned, it hits this point. All right, then we're going to do the same thing to the left. Or you could say flip it over the y-axis, because that's my axis of symmetry going through the vertex here. And the same as that point. And there's my parabola. And because it's y less than my parabola, I want all y coordinates that are below the parabola. So at this point, I'm shading down. Everything is shading downward. So this appears, wait a minute, looks like we're going to have 2 overlapping regions. So it looks like it's these 2, if you will, crescent moon looking shapes that are shaded here. That's my solution set.